Let's take a look at an application of some of the ideas that we have been talking about. So in this problem it says, in a series circuit, the total resistance equals the sum of all the resistances in the circuit. Find the total resistance in this series circuit. So the first thing I want to address is, because there's a lot to unpack here, is first off, when they say that this is a series circuit, that just means there is going to be only one path for the current, and sometimes when you look at these diagrams, the current is referred to as I to flow. Okay, so there's just going to be only one way for the current to flow. If a circuit is not set up in series, it can be set up in parallel, and we'll see some examples of parallel circuits possibly later on in this course. Right, so that's the first thing. The second thing is we're given a diagram for this circuit. So the first thing I want to draw our attention to in the diagram are these lines right here, which refer to the source of the power. So it could be, for instance, like the battery. So when we're looking at the source, there's going to be a short line and a long line. The short line represents the negative terminal, and then the long line will represent the positive terminal. Now the current will flow from positive to negative, so what's going on here is from this positive line, the current will flow in this direction through our circuit, through these resistors, which could, for instance, maybe be like light bulbs in the circuit, and then they will come back to the source and complete our circuit. All right, so then these kind of wavy, zigzaggy marks right here represent resistors. And then in this particular problem, apparently I've got 7 resistors in my circuit. So we're told that the total resistance in all the circuit equals the sum of all those individual resistances. So sum indicates that I want to add all of the individual resistances. All right, so here we go. Let's go ahead and start adding them. Now, the order in which we add them does not matter, so we can just start stacking them. I like to stack the 2-digit numbers on top of each other first, and then do the single-digit numbers. All right, so I would have a 20, a 15, a 12, a 16, a 24, and then my single values of 5 and 3. And again, you could pop this into your calculator, but let's take a moment and just practice some of that column addition that we've been working on. So when I want to go add these numbers up, here's where that commutative property of addition helps me, where I'm going to start maybe grouping them in ways that helps me find the sum rather easily. So this 6 plus 4 gives me a 10, this 5 and this 5 give me another 10, and then this 3 plus 2 give me a 5. So overall, adding that together, I had a 10, and a 5, or 25. I'm going to put the 5 down and then carry the 2 into my next column. Adding the numbers in that column, I've got 2, 4, 6, and then 7, 8, 9. So again, I'm using that commutative property, moving the numbers around and grouping them in ways that make sense and allows me to do the computation a little bit easier. All right, so I'm going to put the 9 down here, and then this measure of the units that I'm measuring everything in is in ohms, which is kind of represented by this kind of upside down U shape with the little lines coming off of it. All right, very good. Let's take a look at another application. So in this one, it says that studs are upright wooden or metal pieces in the walls of a building to which siding, insulation panels, drywall, or decorative paneling is attached. Now, studs are normally placed 16 inches on center and are placed double at all internal and external corners of a building. So the number of studs needed in a wall can be estimated by finding the number of linear feet of the wall. Now the question to us is how many studs are needed for the exterior walls of this particular building. All right, so again, just kind of some basics of what's going on here. So when we talk about these studs, these are going to be these kind of upright pieces right here. So I have this diagram right here which on this side of the wall right here, there would be 1, 2, 3, 4, 5, 6, 7 studs. Now, when they were talking about placing them 16 inches on center, right, just in case you're not familiar with it, we actually don't need to really know what that means to answer this question, but just if you're looking at that and you're getting a little distracted by that, what that's saying is that from the center of this stud right here to the center of this stud right here, that distance is 16 inches. Now we're told that we can estimate the number of studs that we'll need on a wall by finding the number of linear feet of the wall. Right? So given this diagram right here, we want to find out basically how much wall we have. So we're going to kind of walk around this outside edge of this figure and find out exactly how long in feet all those walls are put together. That idea in geometry relates to the perimeter of an object, which is the distance around the outside edge. Okay, so we're going to find the perimeter of this building by adding up all of those distances. Now in this particular picture, they've gone and labeled all of the distances for us, which is pretty nice. Okay, so we're just going to go ahead and add all of them up. Now you could go ahead and put these all in a column, like 32 plus 9 plus 15 plus another 15, and kind of go through and add them all up as a column. But when I see a problem like this, I naturally just start grouping them. So I've got some big numbers right here, like the 48 and the 32. So I already know I'm just going to kind of put those guys down. All right, but then I kind of start grouping the numbers, like this 15 here and this 15 here. 15 plus 15 is 30. So I'm just going to go put that in my list as a 30. What else do I see in here? So I see that I've got this 6 and this 6, which is 12. Okay, so that's kind of really easy for me to do. I can pop that in there. This 10 and this 5 go together to give me a 15. I can drop that in there, and then out of the numbers I have left, this 8 and this 9, if I put them together, give me a 17. Alright, so kind of just a different way to approach it. Especially when you're doing the calculations by hand. Okay, so anytime you can maybe condense some of the calculations, make your life a little bit easier. So you can, for instance, you can add them all up. That's kind of what's going on over here. Or we could start trying to group them to form the numbers that I want to add up. Alright, so in any case, here we go. Let's add the numbers that I have in here. And again, I'm going to try to group these in ways that make it easier for me. So this 8 and this 2 give me 10. This 7 gives me 17, plus 2 more is 19. And then 19 plus that 5 gives me 24. So I'm going to plop down the 4, and I'll carry the 2. So in that column I'll have, let's see, 4, and I'm not saying it really any easy way to do this, so I'll just start adding the numbers down. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is going to be 154 feet around the outside edge of the wall. So then we can assume then, because we're working under the assumption that the number of studs is estimated by just whatever that linear feet is. So we'll need approximately 154 studs.